This is paper for Mechanics 1 M1 from Mathematics syllabus 9709, paper for 1 in May-June 2019. Start from number 1. This is 3 Coplanar vector. We have 7, 8 Newton, 50 Newton, and then 112 Newton. Given that tangent alpha is 12/5 and tangent theta is 4.3, so that coplanar forces shown in the diagram are in equilibrium. I have the max scheme 1. I use the max scheme 1 only. I repeat it to explain it. This is actually in x and y. We split it into direction x and y. 78, this is 5/13 is cos, minus 50 times 3/5, equals to 78 cos 57.4 minus 50 cos 53.1. This is all force in direction x-axis, and then on the y direction, 78 times 12/13, plus 50 times 4.4/5 minus 112 equals on y direction on the positive 1. 78 sine 67.4 plus 50 sine 53.1 minus 112. So we can use it on the direction x and y, on the axis x and y, and then we get x equals to 30 minus 30 equals to 0, and y also 72 plus 40 minus 112 equals also to 0. So all force on the x direction and on the y direction equals to 0. And also we can use sine rule, with force divided by sine of opposite one, it will be equals in other side. This is 112 sine 59.5. It will be same with 50 sine 157.4 and equals to 78 sine 143.1. From the sine rule. So from this we can say, so 112 divided by 59.65 equals to 50 divided 5/13 and equal also 78 divided 3/5. That's equal in 130. So this is in equilibrium. From the sine rule, every force divided by a sine when the opposite one, this is inequally. That's it. Number 2, particle piece projected vertically upward with speed 25 meters per second minus 1 from the point 3 meters above horizontal ground. First question is, find the time taken for P to reach its greatest height. We can use the formula V equals U plus 80, that U is 25, V equals to 0, and then A equals to minus G, or other complete method for finding T. Or we can use V square equals to U square plus 2AS, but it's for time H. For the find the time, you can use this one. V equals to U plus 80, so we get T equals to V minus 2 divided with A. Since V equals to 0 and A equals to minus G, so same thing with 25 divided by gravitational acceleration. 25 divided by 10 equals to 2.5. 2.5 seconds. Second question is, find the length of time for which P is higher than 25 meters above the ground. We can use the approach by using S equals to UT plus a half AT square, with S is 20 and U is 25, and then substitution. Finally we get T equals to 1 and also T equals to 4. And then required time equals to 4 minus 1 equals to 3. second. Or we can using v square equals to u square plus 2as with u equals 25, and then s equals to 20, and acceleration equals to gravitational acceleration, but it's that decelerate, minus g. So after we include this, we get v square equals to 25 square, and then plus 2, g is minus 10, then s equals to 20. Use v at s equals to 10 that to find time t taken to reach the maximum highs, and return to s equals to 20. So we get record time equals to 1.5, and plus also 1.5, that equals to 3 seconds. Third question, p is higher than h meter above the ground for 1 second. Find h. For maximum height reach at 2.5 seconds, hence reach h after 2 seconds, this is equals to h minus 3, equals to VOT or UT 25 times 2 minus a half GT square 5 times 2 square. So we get h equal to 33 meter. Or we can use the alternative solve. Maximum height equals to a half 25 plus 0 times 2.5. This is equal to 31.25. In 0.5, its fall distance, a half of 10 times 0.5 square, so equals to 1.25. So between 31.25, then minus 1.25, and then plus 3, so equals to 33 meter also. Question 3. A lorry has mass 12,000 kilogram. Then question I. The lorry move at a constant speed of 5 meter second minus 1 up a hill inclined at angle of theta to the horizontal, where sin theta is 0.08. At this speed, the magnitude of the resistance to motion on the lorry is 1500 Newton, so that the power of lorry engine is 55.5 kilowatt. So it means driving force equals to resisting force plus mg sin theta. The resisting force is 1500, and mg sin theta it's equal 12,000 times g times 0.08. So we get driving force equals to 11,100 Newton. To find the power, we use the formula. The power is equals to force times velocity. Power equals to force is driving force, and velocity is 5. The driving force is 11,100, then power 11,100 times 5. So same thing with 55,500 watt, or in kilowatt, same thing with 55.5 kilowatt. That's it. Other question is, when the speed of lorry is v meter second minus 1, the magnitude of resistance to motion is kV square Newton. What k is a constant, so that k equals to 60. Yes, we just only substitute that kv square equals to resisting force, so k times v is 5. 5 square equals to the resisting force is 1500, so k means as 1500 divided 25 equals to 60. Question I. The lorry now move at a constant speed on a straight level road. Given that its engine is still working at 55.5 kilowatt, find the lorry's speed. Since we know using by driving force equals to resistance, equals to 60 v square, and then power equals to force times v, so power is 500 watt, so same thing with driving force times v, or equals to 60 v square times v equals to 60 v power 3, and 60 v power 3 equals to 55,500. So after we calculate this, equals to 9.74 meter second minus 1. Question 4. A particle of mass 1.3 kg rests on the rough plane, inclined at an angle theta to the horizontal, where tangent theta equals to 12/5. The coefficient of friction between the particle and the plane is u. Then the question 1 is question I. A force of magnitude 20 Newton parallel to line of greatest slope of the plane is applied to the particle, and the particle is on the point of moving up the plane, so that mu equals to 1.6. The first one, we find about normal contact force as forces perpendicular to plane. This is about 13 cos 67.4, or equals to 13 times 5/13. We get R equals to 5. And result force parallel to the plane, this is equals to F plus 13 sin 67.4 equals to F plus 13 times 12/13, equals to 20. This is equals F equals to 8. So from F, frictional force equals to UR, it means U equals to F divided by R. Same thing with 8 divided 5. 8 divided 5 equals to 1.6. Then the next question, when the force of magnitude 20 Newton is now removed, find the acceleration of the particle. Since 20 Newton is removed, so we'll use formula Newton's second law, that total force equals to ma. So in the parallel line, 13 sin 67.4 minus frictional force equals to ma. That mass is 1.3, so it means 1.3a, and then frictional force is 8. So we get A as the about 40 divided 13, it's about 3/08 meter second minus 2. The next question is find the work done against frictional during the first 2 seconds of motion. We find work done by using formula S first to find S first with T, and then find S as the distance. So after that we find work done by force times distance. For find distance, S equals to ut because u is 0, and then plus a half at squared. A half of A we find before. A is 40 divided 13 and T is 2 seconds. So after we calculate, we get 6.15. So work done, F times D. F is frictional force as 8, and then distance is 6.15. So WD, work done, equals to 49.2 joules. And then the second one, same thing, we find S after 2 seconds, and then we will find work done by difference between potential energy loss negative atau minus kinetic energy gain. Same, we find about distance after 2 seconds, and then same thing, we get 6.15 meter, and then we need to find v, yeah, after 2 seconds. This is equals to 80, yeah. 40 divided 13 plus times 2, yeah. From formula v equals to ut plus, from formula v equals to u plus at, yeah. That we get v, then after we get s and v, work done equals to mgh, yeah. 1 over 3 gh is 80 divided 13 times 12 over 13. This is like length of plane times sine, and then minus a half mv square, a half of 1.3 80 over 13 square as the v square. So same thing, after we calculate these numbers, we get work done equals to 49.2 joules. Question 5 is a particle be moved in a straight line from the fixed point O. The velocity v meter second minus 1 of p at time t second is given by v equals to t square minus 8t plus 12. For t interval is from 0 until 8, yeah. Question I, find the minimum velocity of point P. Using by differentiation of v to find a, we get a equals to t minus 8. So it's mean when a equals to 0, t equals to 4, and then we substitute 4 into equation v, and then we get v equals to minus 4. Then in different solution, yeah, v we use in different equation equals to t minus 4 square minus 4, so we get t equals to 4, and then again we substitute t for second into velocity equation, then become v equals to minus 4 also, minus 4 meter second minus 1. The next question is question II. Find the total distance traveled by P in the interval 0 to 8 seconds.